Hello friends, welcome back. Hearty welcome to you. Let us look at this interesting problem. Find the area of the quadrilateral bounded by the angular bisectors of a parallelogram with sides A and B and angle alpha. So we have a parallelogram ABCD. Now we want to find out the area of this quadrilateral PQRS, which is formed by joining the angular bisectors of the parallelogram. So we have AR, then BR, CP, DP. These are all angle bisectors. When they meet with each other, the area bounded is PQRS area. That is, now we have to find out the area of that particular quadrilateral. So to proceed with the problem, let's understand what will be PQRS, what type of quadrilateral PQRS will be. So for that, they have given us extra information. They said that sides are A and B and the angle of parallelogram is alpha. Since it is an angular bisector, now alpha is divided into alpha by 2, and when we go to angle at D, we know that A plus D is 180 degrees because we have adjacent angles supplementary in a parallelogram. So, and that is divided into two equal parts. So, we have 90 minus alpha by 2, 90 minus alpha by 2. Similarly, at B and C also. Now, when we do angle sum property on the triangle ASD and BQC and ARB and DPC, we can see very clearly that each of these angle is equal to 90 degrees. So what we have now is a rectangle. So PQRS is a rectangle. So let's go ahead and put those 90 degrees there. So we know that all these are 90 degrees. That means so we have 90 degrees. So we can say that PQRS is a rectangle. So we can straightforward say that PQRS is a rectangle because all the angles are equal to 90 degrees. Now once we know PQRS is a rectangle, what is the area of a rectangle length into breadth? So can I say that area of PQRS is equal to RS into RQ. Now what is RS? RS is nothing but equals to AR minus AS. Multiply that with RQ, which is BR minus BQ. Now let us see what is AR and what is AS. If you take this triangle ABR, you can look from here. What we want to find out is AR. AR is adjacent side. So cos alpha by 2 will give you AR divided by A. Or can I say AR equals to A into cos alpha by 2? So we can say A into cos alpha by 2 minus AS. AS is B into cos alpha by 2. We can check that from the triangle ASD, B cos alpha by 2. Multiply that with BR. BR from triangle ARB, we can see that BR is actually A sin alpha by 2. And BQ from triangle BQC, we can see that BQ equals to B sin alpha by 2. Now let us simplify this. What we have is A minus B whole square into sin alpha by 2 cos alpha by 2. We can leave it like that, or we can write it as half into A minus B whole square into sin alpha, because we know that sin alpha equals to 2 sin alpha by 2 cos alpha by 2. So let's have a recap of this problem. we have been asked to find out the area of the quadrilateral, which is bounded by the angular bisectors of the parallelogram. So now the angular bisectors are drawn. Then we found out that whatever the quadrilateral we are looking for, that's a rectangle, because we have adjacent angles are supplementary in a parallelogram. So we have alpha by 2, 90 minus alpha by 2, 90 minus alpha by 2. Now let us look at this triangle ASD only. Angle sum property will give you 90 degrees. That means angle at S is 90 degrees. Similarly, triangle BQC, angle at Q is 90 degrees. That means angle at Q inside the quadrilateral is also 90 degrees. Now look at triangle ABR. We have directly angle at R in quadrilateral is 90 degrees. So we have all the angles are equal to 90 degrees. Now what we need to find out is just area of the rectangle. Now area of the rectangle is length into breadth. So we can say RS into RQ. But we can't find out what is the value of RS. So we just thought that we will write it as AR minus AS, because AR can be obtained by ABR triangle and AS can be obtained by ADS triangle. Applying trigonometric ratios, we got AR is A cos alpha by 2, AS is B cos alpha by 2. Similarly, BR is A sin alpha by 2 and BQ is B sin alpha by 2. Now when we multiply them, we got A minus B square into sin alpha by 2 into cos alpha by 2, but that can be written as half into A minus B whole square into sin alpha. So the area of the quadrilateral bounded by the angle bisectors of a parallelogram with sides A and B, angle alpha is half into A minus B whole square sin alpha. So that's one interesting problem which I have found when I'm going through the problems in plane geometry. So I just thought I'll share that with you, because that's not a problem from the regular textbook. So please let me know your feedback. Thanks for your time and support. Love you. Take care.